Space-time isn't a stage, it's a participant. Most people imagine space as an empty box and time as a clock ticking somewhere outside the universe, just watching. That picture is completely wrong. Space and time are woven together into a single fabric, and that fabric bends, stretches, and warps depending on what mass and energy are sitting on it. A planet doesn't get pulled toward the sun by some invisible rope. It rolls along a curve in space-time the same way a marble rolls along a dip in a stretched rubber sheet. There is no pull, there is only geometry. This is shocking the first time you really sit with it, because it means gravity isn't a force at all, in the way you think of a push or a shove. It's the shape of the universe itself steering you. Your GPS satellite has to correct for this every single day because time actually ticks faster for it up there, farther from Earth's mass, than it does for you standing on the ground. That's not science fiction, that's Tuesday. And yet, here's the uncomfortable part, nobody can tell you what space-time is actually made of. Is it a substance? A field? Information? We can write the equation for how it bends beautifully. We cannot tell you what is doing the bending. We've mastered the choreography without ever meeting the dancer. Two great theories that refuse to shake hands. We have two of the most successful theories human beings have ever built. One describes the very large planets, galaxies, falling apples, curving space-time, all smooth and continuous like a calm river. The other describes the very small electrons, photons, atoms, and it's jumpy, probabilistic, twitchy, nothing like a smooth river at all, more like static on an old television. Separately, both theories work with terrifying precision. Put them in the same room, though, and they start screaming at each other. Try to describe gravity using the rules of the small stuff, and the math explodes into meaningless infinities. Try to squeeze quantum weirdness into smooth space-time, and it refuses to fit, like trying to pour the ocean into a teacup. This isn't a small technical glitch we haven't gotten around to fixing yet. It's a fundamental crack running through the foundation of physics itself. Every particle in your body, right now, is being governed by quantum rules. Every inch of the space you're sitting in is being governed by relativity's rules. And those two rule books were never written to agree with each other. We are quite literally made of a contradiction we haven't solved. Black holes, where the universe stops making sense. Fly a spaceship toward a black hole, and something extraordinary happens to the equations of physics long before anything happens to your ship. At the center, sitting in our best mathematics, there's something called a singularity, a point where density becomes infinite, where curvature becomes infinite, where space-time itself seems to just stop existing as a coherent idea. Infinity is not a real answer in physics. Infinity is nature's way of screaming at you that your theory has broken down. It's like a calculator that gives you error instead of a number, not because the universe actually contains an error, but because your model has hit its limit. And it's not just an abstract curiosity floating out in deep space either. We now have photographs of the shadows these things cast. They are real, sitting out there in the dark, quietly outperforming our best theories. Every single day, something is happening at the heart of a black hole. Matter is going somewhere. Information is doing something. And whatever that something is, our equations simply throw up their hands. If you want a single honest symbol for how much we don't understand space-time, don't look at a chalkboard, look at a black hole. It is the universe politely telling brilliant people that they are still missing something enormous. Why does time only move forward? Here's a strange little fact that should bother you more than it does. Almost every fundamental equation in physics works exactly the same, whether time runs forward or backward. Play a video of two particles colliding, then play it in reverse. The mathematics doesn't complain either way. Yet you have never once seen a shattered coffee cup leap up off the floor and reassemble itself back onto the table. Time, in your actual lived experience, has a direction, an arrow, and physics' deepest equations barely explain why. The best answer we have involves something called entropy, the universe sliding, statistically, from order into disorder, simply because there are astronomically more ways to be disordered than ordered. But notice what that means. The flow of time you feel every waking second may not be a basic ingredient of the universe at all. It might be closer to a side effect, an emergent illusion arising from probability in large numbers. The way a wave in a stadium crowd isn't a real object, just a pattern people create by standing up in sequence. If that's true, then the most personal, most obvious thing you experience, time passing, might be one of the least fundamental things in existence. Maybe space-time isn't even fundamental. Now here comes the part that keeps serious physicists up at night. What if space-time itself is not one of the basic ingredients of reality, but something built out of deeper stuff? the way a smooth, solid-looking table is actually built out of jittery atoms, mostly empty space. It is a strange and beautiful idea, sometimes called the holographic principle, suggesting that all the information describing a three-dimensional chunk of space could be encoded on its outer boundary, like the universe is somehow a projection. There's another idea, connecting black holes and quantum entanglement, suggesting that the very geometry of space-time, its distances, its connections might be stitched together out of particles being entangled with one another. Distance itself might be a kind of relationship, not a container. Picture that. The empty gap between your hand and this page might not be empty nothingness at all. It might be a pattern of hidden quantum threads, and space is just what those threads look like from the outside. If any of this is right, then asking what is space-time made of is a bit like asking an ant standing on a brick wall what the color red is made of. The ant is standing on a pattern far larger than anything it can directly see, the honest limit of what we can know. And now for the part nobody likes to admit out loud. Every instrument we've ever built, every intuition we carry in our skulls, evolved to survive on a single dusty planet, chasing food, avoiding predators, judging the distance to the next branch. None of that biological hardware was built to directly perceive curved four-dimensional geometry or quantum entanglement stitching space together. We are in a very real sense using Stone Age brains to interrogate the architecture of reality itself, and it's remarkable we've gotten this far. But remarkable isn't the same as finished. Every time physics has declared we basically understand this now, nature has cheerfully proven it wrong within a generation. Space-time may be the next humbling. Admitting we don't know is not a failure of science, it is the entire engine of science. The moment you think you've fully understood something as deep as space and time, you've probably stopped looking hard enough. The universe has never once been obligated to make sense to a species that only recently learned to make fire. What if the ground under your feet, the air between your hands, the seconds slipping by right now as you listen to this, what if none of it is what you think it is? What if the very thing you're swimming through your entire life is the one thing modern physics still cannot honestly explain? You've been told, probably in school, that space is just emptiness, and time is just a clock running quietly in the background. Forget that. Space and time are stitched into a single fabric, and that fabric bends. A planet doesn't get yanked toward a star by some invisible chain. It simply rolls along a curve carved into space-time itself, the way a marble rolls along a dip pressed into a stretched sheet. Gravity isn't a pull, it's a shape, and the satellite hanging above your head right now has to correct its clock every single day because time itself moves faster up there than it does down here. That is not a theory tucked away in a textbook. That is your phone right now, quietly relying on bent time to tell you where you are. But here's where it gets uncomfortable. We can describe how space-time bends with jaw-dropping precision. We cannot tell you what is actually doing the bending. We've choreographed the dance without ever meeting the dancer. And it gets worse. We have two great theories of nature. One handles the enormous stars, galaxies, falling apples, smooth, continuous, elegant, like a calm river. The other handles the tiny electrons, photons, jumpy, twitchy, probabilistic, like static on an old radio. Alone, each one is spectacular. Together they refuse to cooperate. Try to combine them, and the mathematics explodes into nonsense, infinities appearing where no real number should ever appear. And infinity, in physics, isn't a mystical answer. It's nature grabbing you by the collar and telling you that your theory has hit a wall. Nowhere is that wall more obvious than at the heart of a black hole, where density and curvature shoot off toward infinity, and our equations simply give up. We have photographs of these things now, sitting quietly out in the dark, outperforming our best minds every single day. Something extraordinary is happening in there. We don't know what. And then there's time itself, the strangest character in this whole story. Nearly every fundamental equation in physics works exactly the same whether time runs forward or backward. Yet you've never seen a broken coffee cup leap off the floor and reassemble itself. That one-way arrow you feel every waking moment might not be a basic feature of the universe at all. It might be closer to an illusion built out of probability. The way a wave rippling through a stadium crowd isn't a real object, just a pattern people create by standing up one after another. Which brings us to the strangest possibility of all. What if space itself isn't fundamental? What if it's built out of something deeper, the way a solid table is secretly just jittery atoms and mostly empty gaps? Some of the sharpest minds alive now suspect that distance, connection, geometry itself might emerge out of quantum entanglement, particles linked to one another in ways that, from far enough away, simply look like space. The gap between your hand and this page might not be nothingness. It might be a pattern of invisible threads, and space is only what those threads look like from where you're standing. And maybe that's the real lesson buried in all of this. Every tool we've built, every instinct wired into our skulls, evolved on a single dusty planet, chasing food, avoiding danger, judging the distance to the next branch. None of it was built to directly grasp four-dimensional curved geometry or quantum threads holding reality together. It is genuinely astonishing we've come this far using brains built for none of it. So no, we still don't know what space-time truly is. Not really. We know how it behaves, we know how to calculate its curves, predict its bending, correct our satellites for its tricks. But the raw, honest question of what it is made of remains wide open, sitting right at the edge of human knowledge, daring the next curious mind to step closer. And that's not a defeat. That is the most exciting sentence in all of science. We don't know yet. Every great discovery in history began exactly there, in that uncomfortable, thrilling gap between what we've measured and what we understand. The universe has left the door open. Somebody just has to walk through it. What if everything you've ever trusted, the ground holding you up, the clock on your wall, the empty space between your outstretched hands, what if none of it is actually fundamental? What if space and time aren't the stage the universe performs on, but something the universe quietly built, the way a table is built out of atoms you'll never see with your own eyes? Right now, satellites above your head are running on bent time. Black holes out in the dark are breaking our best equations every single day. And the direction time flows, the one thing you feel every waking second, might just be an illusion made of probability. We've mapped the behavior of space-time with stunning precision. We still don't know what it actually is. And over the next few minutes, I'm going to show you exactly why that question might be the most important one physics has left to answer. So stay with me, because by the end, you'll never look at empty space the same way again.